Hello everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent, and in this video clip I want to give you some examples for statistical hypothesis testing. And when we test hypotheses, we usually compare two different samples. So let's say we compare the means of two different samples. So sample 1, we got a mean or an average, and we call that x bar 1 of a certain value, say 175 centimeter, whatever this experiment was. Sample 2, we get another average, we call it x bar 2, and we say this is, say, 189 centimeters. And we want to know whether both samples are part of the same population, or whether both samples come from the same population. So the first thing that we set up is the null hypothesis, so H naught in this case, and H naught is always written as there is no difference. There is no difference between the sample means. The sample means other than due to sampling error. So the only difference between these two sample means is the sampling error. And we can write this mathematically. We can say x bar 1 is the same as x bar 2. Of course, they are not identical here, but any differences between these two are just the sample error. And we can state our alternative hypothesis, which is exactly the opposite of the null hypothesis. We say there is a difference between the sample means caused by something else, on top of the sampling error. So on top of the sampling error. So there is more to it. And we can say x bar 1 is not the same as x bar 2. We don't say whether x bar 1 is larger than x bar 2 or whether it is smaller than x bar 2. It could be both. We just say it is different. So, like that. It is different. And so, how do we find out whether they are different? We calculate our p-value, and we can do that with different tests. And we compare this p-value to a critical significance level, which we set before we do the calculation. Critical significance level. This is abbreviated alpha, and very frequently this is set as 0.05. So in our experiment, for example, we calculated a p-value, the probability that these two samples are from the same population in this case would be, say, 0.17, and we compare this 0.17 to this critical significance level, and we know that if P is low, so if P is lower than alpha, P smaller than alpha, then H naught must go. If P is high, so if P is larger than alpha, then H naught can stay. So in our example here, we have the p-value is larger than alpha, so 0.17 is larger than 0.05, and therefore our H naught can be accepted. So we can say there is no difference between the means of the samples. Running out of space. So let's do a few more examples. Let's say our alpha is 0.05 and we compare two samples. The p-value in this case is 0.001. So here we've got p is smaller than alpha. If p is low, H naught must go, and therefore we can say we cannot accept our H naught. Instead, we have to accept our alternative hypothesis. Let's do another example. Let's say alpha equals 0.01. We can choose alpha, whatever we want. P equals 0.08. So in this case, we have P is larger than alpha, 0.08 to 0.01. And we say if P is higher than alpha, if P is high, then H naught can stay. And in this case, we say, yes, we can accept the null hypothesis and we do not accept the alternative hypothesis. So I hope with these examples you understand that comparing the p-value to the alpha, to the critical significance level, is a very simple process, and we can very easily accept or not accept our null hypothesis. And this null hypothesis is a very formulaic process. It always says, the null hypothesis always says that the two samples that we compare are not different. So hopefully this makes sense, and thank you for watching.